Hello, I'm Christian, and this is our water project.
Hello everybody, my name is Christian Andregg, and I'm here with the other two bozos, Sean Englehardt and David Roll. You'll be seeing them in a little bit, and welcome to our chemistry project for Mr. Carson's class. We're going to be talking to you about water. Enjoy. So anyways, we're going to hop right on into talking about molecular structure. And I really apologize for what you're about to see. Here is our representation of a water molecule and how it's formed. Oh God, why?
Go.
As atoms of two or more elements combined and joined chemically, the product of the reaction creates a new substance. And together we make water. 1 oxygen and 2 hydrogens.
So, that was us. In all our moob grabbing awkwardness. But anyways, water is made up of 3 atoms altogether, like we showed you. There's the 2 hydrogens, which was Sean and David, and the 1 oxygen, which was me in the middle. The 3 atoms form an angle at approximately 104.5 degrees, and the center of the hydrogen atoms is approximately 0.0957 nanometers away from the center of the oxygen atom. Now, in order to find out the molecular weight of H2O, we need to take the atomic weight of every atom in the molecule, which isn't that hard. All you need to do is look at the periodic table for reference. Now, oxygen has an atomic weight of 16, while hydrogen has an atomic weight of 1 per each of them, and we have 2 hydrogen atoms. So, if you add them up together, it should just be 16 plus 1 plus 1, which should equal 18. The molecular weight of H2O is 18. Now, the next thing we decided to cover about our trusty little friend H2O is surface tension. Surface tension is the contractive tendency of liquid that allows it to resist external force. It's the reason that things float even though they may be denser than water. For example, the water strider is an insect that takes advantage of this contractive tendency and walks across water using the surface tension. We also did cover this in class when we did the paperclip lab in class with Mr. Carson, where we made the paperclips float on top of the water. And now, here's a video of our friend Sean trying to test the surface tension of a freezing cold pool with his belly flop. All while I try to explain the cause of surface tension.
The cohesive forces between liquid molecules are responsible for the phenomenon known as surface tension. The molecules at the surface do not have other like molecules on all sides of them, and consequently they cohere more strongly than those directly associated with them on the surface. This is surface tension.
Next, we're going to be talking about all the different forms of water. First, we're going to be talking about ice. Water turns into ice at its freezing point, and once water hits this freezing point, it solidifies into those little tiny cubes that we like to put in our tea. Here's this next video of some ice being chucked at me.
Oh no! 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 Ah! Ow! No!
Now, the exact reason that water turns into ice is because of the molecules. When you freeze water, the molecules get tighter and closer together. thus creating a solid. Now that leads me into my next form, the liquid, because it's essentially the reverse. When you heat up ice, the molecules expand and they get more room to move around. Here's a video of me getting the same exact treatment, just this time with a liquid. Now, building off of that, if you heat up water even more, then the molecules will move around so fast that they can't even hold on to each other anymore and they fly apart, creating a gas or vapor. Now, we can't exactly show you me getting hit with vapor on a bicycle, but we can show you this picture of us possibly surrounded by vapor. I don't know, let's see if you can spot it. Density is the degree of compactness of a substance. The density of pure water is actually somewhat less than 1 gram. Here is a table listing the values for the density of liquid water. The solid form of most substances is denser than the liquid phase. Thus, a block of most solids will sink in the liquid. However, a block of ice floats in liquid water because ice is less dense. Upon freezing, the density of water decreases by about 9%. This is due to the cooling of intermolecular vibrations, allowing molecules to form steady hydrogen bonds with their neighbors. Pure water containing no exogenous ions is an excellent insulator, but not even deionized water is completely free of ions. Water undergoes autoionization in its liquid state, when 2 water molecules form one hydroxide and neon, or OH negative, or negative OH or something, however you say that, and one hydronium cation, which is H3O plus symbol at the top. I don't know how to say that. Because water is such a good solvent, it almost always has some solute dissolved in it, often salt. If water has even a tiny amount of such an impurity, it can conduct electricity far more readily. Alright, that's it everybody. We'd like to thank you here for watching our chemistry project. We hope you really enjoyed it, and we hope that it all goes well. Just gonna leave you guys with that. Love you guys. Bye.